Hello students, my name is Kumar Gupta and I am working as an assistant professor in the department of MCA in IIMT College of Engineering, Greater Noida. Today I am going to deliver the lecture on process and its scheduling. It is a very important topic in the paper operating system. So we will go in detail with its content like its definition, process control block, its life cycle, process scheduling with its type, and what are the schedulers. So, firstly, we must know the definition. What is the process? Process is an instance of the program that is being executed. Students, what is program? Program is basically the collection of instructions, or the collection of instructions is called program. When the program is being executed by the CPU, so at that time, that program becomes a process. In another way, we can simply say when the program is loaded into the memory, then it becomes the process. Process is more than a program code. It is also known as the text section. It also includes the current activity as represented by the value of program counter. So it will be divided into the four sections I have given here. The sections are stack, heap, text, and data. So we will come to the first point, that is stack. What is the stack? Stack contains the temporary data like function, method, parameter, return address, etc. Now come to the next point, that is heap. The memory is basically allocated by two types. First type is runtime allocation and second type is compile time allocation. We are talking about the process. Obviously, it will be the runtime. So the runtime allocation of memory will will be under heap. Now to the next, the text. What is the text? It includes the current activity that will be represented by the program counter and the processor registers. So what is the program counter? Program counter is that which keeps the record of the instructions which is going to be executed next by the CPU. Now, the last point is data. Data is basically collection of the variables, or it will be the collection of global and local variables. We must know what are the global and the local variables. I am going to explain it with a short example. Suppose we are having a function main, and we are going to declare a particular variable inside the main function. Then that case, the variable which is declared inside the main function will be the local variable to the main function. But in opposite, if the variable is declared outside the main function, then that variable will be global to the main function. So I hope you people will be able to understand the definition of process. Now we will move to the next, that is PCB, process control block. There are so many processes in the computer system, and these processes are kept in a job pool, in a pool. Basically, that pool is known as job pool. All the processes are picked up from the job pool. So, process control block, it is a basically the data structure which is able to uh, keep the record of the process. So this is called PCB. We can understand it with the help of a block diagram. I have given here the block diagram. So there are some states, process states, process number, program counter, register, memory limit, and a list of open files. First point is process state. There are five states in a process. I will tell you later what are the process states. Now the process number. As we all know, the number may be the roll number, sequence number, ID number. In the same way, there will be the process number. It will be start from 0, 1, 2, 3, and so on. Now, the next is program counter. Program counter means I have told you program counter is able to keep the record of instructions which is going to be executed by the CPU. Next is register. Registers are basically CPU registers. CPU register means it may be the accumulator, it may be index register. So these are the registers. Next is memory limit. Memory limit means the memory management technique. It will be able to keep the record of accounting, storing information, and so on. And list of open files. So this is the process control block. Mean to say how the process is being executed. It is represented with the help of block diagram. Now, I have told you the state, process states. There are 5 states of the process: new, ready, running, blocked, and terminating state. So what is the new state? When the process is creating, firstly, process will be created or process will be initialized. In that case, the process is called, it is in new state. Now, the next is ready state. Suppose the process is being created and it is waiting for its execution. Mean to say, it is waiting, basically it is waiting for the CPU allocation. At that time, process has to wait until the CPU is not being assigned. So it will be in ready state. Now the third state is running state. Running state means the name, as name seems, running state means the process is being running by the CPU or it is being executed by the CPU. So it will be in running state. Now the blocked state. Blocked state basically known as the waiting state. Suppose if a process is in running state and at that time another process wants the CPU, another process wants the CPU at the same time. So that process has, the first process has to wait for some time and that time the CPU is assigned to the another process. So first process has to wait. It is because the process may be of higher priority, process may be any event may be occur at that time. So the process has to wait for some time. Now the last is terminating state. The process completed its execution completely. So it will be in terminating state. Mean to say, after terminating state, we are able to get the result or we are able to get the output on our screen. So these are the 5 states of the process: new, ready, running, blocked, and terminating. We can understand it with the help of a process state diagram. Process, this is known as the process life cycle. So as I have given you the new, ready, running, blocked, and terminating state. So here the states are start, ready, running, terminating, and waiting state. Firstly, running. Firstly, the start. Start means the process is being created or the process is being initialized. As I have told you, it will be in start. Next, in ready state, the process is waiting. The processes are waiting for assigning the CPU. Mean to say, it is waiting for assigning the CPU. The process are kept in the ready state. If this is the running state, from ready state to running state, the process is moving to running state. In running state means the CPU is executing the particular process. If the process get an event, if any event is occurs or any higher priority process comes, then from running state the process has to in this state, that means waiting state. You can understand it very we can very simple example. Suppose a process P1 is executing by the CPU and at that time process P2 comes for its execution immediately. At that time P1 have to in waiting state and P1 will be in waiting state and P2 will be in running state. From waiting to it will move to the ready state and from ready to again in running state. So this is the main concept. From running state, if the process is completely executed, then it will move to the terminating state. In terminating state, the output comes or process complete its execution. Next, how the process are scheduled. My students, Scheduling means process are being scheduled. So which process will be executed by the CPU first and which process should be executed next and so on. So there will be the concept of scheduling. There are two types of the scheduling. First type of scheduling is preemptive scheduling. I will tell you, and another scheduling is non-preemptive scheduling. Preemptive scheduling means we can understand it very easy example. Suppose there is a process number 1 and process number 2. Process number 1 is holding the CPU for its execution. At that time, process number 2 comes and it also wants the CPU for its execution. In that case, the CPU switch from process number 1 to process number 2 for a particular amount of time. Suppose 5 seconds. So the process will be executed for 5 seconds and again the CPU return to process number 1 for 5 seconds and it will be so on. Mean to say the CPU is switching from process number 1 to process number 2, right? So in that case, CPU, the switching of CPU is known as context switching. Okay, so this is called preemptive scheduling. Mean to say process switches from running state to ready state. In other words, we can simply say running to ready or waiting to ready state. And the CPU is switching from process 1 to process 2. This is called preemptive scheduling. There are preemptive scheduling algorithms like RR, round robin scheduling, shortest remaining time first scheduling, priority scheduling, preemptive scheduling, non-preemptive type. This is the only scheduling priority algorithm which comes under both. So this is the preemptive scheduling. In preemptive scheduling, CPU always switches from one process to another process. Next scheduling is non-preemptive scheduling. In a non-preemptive scheduling, it is the totally opposite of the preemptive scheduling. Means process number 1, if the process number 1 is holding the CPU for its execution, it will not release the CPU until and unless it completes its execution. If it completes its execution, then it will release the resource, that is CPU, and after releasing the resource, it will be given to the another process, that is process number 2. So once the resource is allocated, mean to say if the resource is allocated to a particular process, it holds the CPU till the till it gets terminated. Okay, so this is the main difference between preemptive and non-preemptive scheduling. In preemptive scheduling, there will be the context switching, but in non-preemptive scheduling, no concept of context switching will be there. The algorithms of non-preemptive scheduling are shortest job first. It is also known as SJF, and the priority scheduling, non-preemptive scheduling version. It comes as I have told you in my previous slide. Priority scheduling and non-preemptive scheduling, it comes in both. So who will schedule these processes? Who will schedule these processes? For this, the scheduler comes. Okay. So what is the scheduler? We must know what is the scheduler and how the processes are scheduled. Scheduler are basically system software that handles process scheduling in different ways. The main task of the scheduler is to select the process and submit it to the system or submit it to the computer system for its execution. So this is the main work of the scheduler. So the question is here, how many types of the scheduler? Now, there are the types of scheduler: long-term scheduler, medium-term scheduler, and short-term scheduler. Basically, there are three types of the scheduler. So first type is long-term scheduler. It is asked to many competitive exams. What is job scheduler? The job scheduler is the name of long-term scheduler. The long-term scheduler determines which programs or processes are admitted to the system for the process. It selects the process from the queue and loads them into memory for its execution. In another way, if the program are residing in secondary memory, from secondary memory to main memory, from secondary memory to the main memory. The transfer of processes from secondary to main memory will be accomplished by the long-term scheduler, right? And after that, from main memory, it transfers to the CPU. But there will be another memory. There will be the another memory which will be consisting the place inside the main memory and the CPU. That is known as the cache memory. My students, in cache memory, the processes are kept which are going to be immediately executed by the CPU. Those processes are kept in the cache memory. So from the cache memory, all the processes are picked up by the CPU for its execution. So this is a very important concept of cache memory which resides under the main and the CPU. Now, the second scheduler is short-term scheduler. Short-term scheduler is also known as CPU scheduler. Mean to say, the process is being allocated to the CPU, or process allocated to the process is being holding the resource, that is CPU. Okay, so CPU scheduler selects the process from the different processes and execute them, and after executing we are able to find out the result. So from secondary to main memory, the work of long-term scheduler is accomplished, and from main to CPU, short-term scheduler accomplished its work. Another work of medium-term scheduler. Medium-term scheduler is a part of swapping. It removes the processes from main memory and reduces the degree of multi-programming as well. Mean to say, it is basically swap in, swap out. I am going to explain it in detail. Suppose the process P1 is executing and at that time P2 wants the resource. Then resource means CPU. In that case, it is compulsory to assign the resource to the process P2. In that case, P1 have to wait for it some time. Mean to say, it may be the blocked or it will be in waiting state. This work actually will be accomplished by the medium term scheduler. There is a very short differences between these three schedulers. The work of long term scheduler from secondary to main, the work of short term scheduler from main to CPU, the work of medium term scheduler from scheduling is running state to running to waiting. This is the work of medium term scheduler. So I think you people are able to understand what are the differences between these three schedulers. Now we can understand it with the help of a diagram that I have given you. This is the job pool, and from job pool, there are so many processes. From job pool to the ready queue, the processes are taken out with the help of long-term scheduler. There will be the so many processes which are waiting for the assigning of CPU in ready queue. From the ready queue, the processes are assigning to the CPU. It will be accomplished by the short-term scheduler. In CPU, the process are running or the process are being executed by it. In this case, if any event occurs or by any reason the process have to wait, then it will be accomplished by the medium term scheduler. I have mentioned here input output waiting queue, and after this the process again go to the ready queue and select the process by the short term scheduler and assign to the CPU, and after completing its execution it will be exit. Mean to say, in simple words, the process completes its execution and able to produce the output. So this is the main difference between the long term, short term and medium term schedulers. So my students, I think you people are able to understand what are the process, how to execute, and what are the schedulers. In next slide, we will move to the scheduling algorithms with the help of suitable examples. Thank you.